Hi, welcome back to the Shuko Math Practice Lab, Learning Through Practicing. And this is our practice set number 3 on the optimization problems. And the previous two videos, we talk about the level 1 and the level 2 optimization problems. And for this video, we're going to talk about the level 3. And so the problems here will be a little bit more complicated than the other two videos. But the basic procedure and the steps are still the same here. Okay, so let's take a look what type of the problems we're going to do in this practice set. So in this practice set, we're going to work on these 3 problems. Basically, is try to find the dimensions of the certain figures and with certain condition. All right, so now let's go ahead and go to our worksheets here, and let's try to start to work on that. Okay, so the first ones here, they say to find the dimension and of the rectangle of the largest area that can be inscribed on the equilateral triangle. The side of this equilateral triangle, the length is L, and so this is equilateral. And then also we know the one of the rectangle that lies on the base of the triangle. So let's always, so what do we need to do? Let's first graph it, right? So let's say this is equilateral. So this is the L, this is the L, and this is the L. And I'm going to find rectangles here. So the rectangles here is sitting over here. All right. And then we have like this is a height going down here. My not quite, but you see here, that's what is the we want. So like always, we want here, let's find our objective functions, right? So objective function is we want to find the largest area. So the area, this is what we want to maximize. Okay, so to find the largest area, so now we can mark it. So let's see here, if this is Y and this is X here. And so the largest area here, I did not draw kind of the proportional, but we know if it's equilateral, you divide this angle going down here, right? Then this will be equally divided. So the area of this rectangle will be what? Will be the 2xy's here. And what do we want to do? We want to maximize it. Okay. Now for this problem, the kind of the hard part is try to find our constraints or the conditions we need to follow here. So let's see, how do I, okay, so how do I combine the X and the Y's here? Okay, so now let's take a look here, right? So in here for these triangles here, because this is equilateral, so this is what degree? This is 60 degrees, correct? So this is 60 degrees. So if in here, okay, so let me draw these different colors here. If this one's here, right? So if this is my height of these triangles here. All right, so the height of the triangle, because this is 60 and this one is equally divided, so this is 30. So I know this triangle is 30, 60, and 90 degrees. So it is a special triangle. So the special triangle, because the L is faced the right angle, so the height is faced 60. So I know the ratio is square root of the 3/2 for the hypotenuse here, right? So I know here the height is equal to the square root of the 3/2 here. All right. So the height is the square root of the 3/2 to the L here, right? Okay, because of the special triangles here. And now the problems here, okay, I got the height, but how do I put the X and the Y together here? So this is the first thing. So we need to use the similar triangles. Let me see here. All right, so, okay, so if you take a look at this small red triangle, see here, right? So if you take a look at this small red triangle and compare to, I color this one, see here, this one, the big triangle, the yellow ones here, right? So what is their relation? They are the similar triangle. If they are the similar triangle, then I can use the ratios, right? So let's take a look at these red triangles here, right? The height is the square root of the 3 over 2, right? So for this area, so for this side here, right? So this side of this red triangle, it will be what is the square root of the 3 over 2 of the L minus what? Minus y, right? So you got this here, the black lines here. And this small red triangle, then this side versus the x here, right? Okay, so it's the square root of the 3 over 2 minus L minus y over x. And this one is going to be, because the small red triangle and this big yellow triangle, they are the similar triangle, so the ratio will be the same. So the ratio of the small red triangle here, so will be the large triangle in where the will be the what will be my height, right? Okay, so will be my height here, right? So the height is here, like we said before, the height, and then what is the bottom here? This will be the L over what? L over 2 here, because L is a fixed number, right? So this is the fixed. In fact, this is a constant. So now let's do a little bit of simplification here. This is the square root of the 3 over 2, the L minus y, the x. So what is h? H is the square root of the 3 over 2 to the L. Now here, this is L over 2 here. Okay, so then take a look at L cancel. 2 and 2 cancel. Whoa, we get a pretty good results here, right? So we have square root of the 3 over 2, the L minus y of the x equal to what? Square root of the 3. Correct? Okay, so we get the square root of the 3, and now I can do a cross product. So I said the square root of the 3 over 2, the L minus y is equal to the square root of the 3, the what? Square root of the 3 x here, right? So now I can solve for y. So now in here, and I move up here. So if I move up here, then I know y is equal to what? Square root of the 3 over 2, the L, minus the square root of the 3, the x. Correct? All right, so now I finally, like I said, for this problem, the hardest one is to try to see, how do I change to the one variable to be the function of the other ones, right? That's from our steps here. Okay, so my conditions here, right? So subject 2, so basically the subject 2 is here. So that means I have the the square root of the 3 over 2, the L minus y over x equal to the square root of the 3. Now I can solve for the y. So now I can substitute the y to the area. So it's 2 times x, and the y, this is the square root of the 3 to the 2, the L minus the square root of the 3, the x here. Correct? Okay, so now I can move the square root of the 3 out. So this is the square root of the 3. Then you times the, so you've distributed the properties. So what is here? So this will be x to the L, right? So x to the L, and then minus what here? The x squares, right? So you will be the, so x to the L and x square. All right, so this is the So this is a 2x squares, right? Be careful, right? So you did a distributive properties, xl to the 2x square. And I know the x is here. So I know the x should be vary from some 0 to the L over 2 because this is the halfway, right? Okay, after that, then the problem is pretty easy. So like I said, the hardest one is sometimes find objective function, sometimes find your constraint, your conditions here. Now you take the derivative. So the derivative here, this is square root of the 3. So this is the L minus what? Minus 4x equal to 0. So right now you solve it. So the x equal to what? L over 4, right? So let's check to see if x equal to L over 4, do I really get the maxima over minima? So this is L over 4. So this is A primes here, right? So as you can see, if you put something less than L over 4, you will get a positive. If you put something greater than L4, you will get a negative. So your function is increasing, decreasing. So yes, you're going to get a what? You're going to get a max here. So I know the L over 4 will give you the maximum area. Okay, x equal to the L over 4, then let's substitute to the y. So the y here will be the square root of the 3 over 2 the L minus square root of the 3 times L over 4. So it will be square root of the 3 over 4, the L. So the dimensions here, right? So this will be our dimensions. So the x will be the L over 4. So this is our answers, right? So this is our dimensions here. So x is L over 4 and y is the square root of 4 square root of 3 over 4 the L. So what is the max area? So the max area will just be the 2 times L over 4 times the square root of the 3 over 4 to the what? To the L's here, right? So now you can just simplify a little bit. So it's the square root of the 3 over A to the L square. That will be the largest area for this rectangle. So be very careful, right? So this problem here is you need to be able to recognize, how to use a similar triangle. We used this technique, when we did a related rate problems here, right? So when you find the similar triangle, then you try to compare the ratio of that. Okay, now let's take a look at the other ones here. Okay, so the other ones here, the second ones here is find the area of the largest trapezoid that can be inscribed in a circle of the radius is 1 and whose base is a diameter of the circle. Okay, so now let's see, let's graph it first and then let's see what can we do. All right, so how do we set it up? So here, this is my circles, right? So this is my circle and the radius here, let's say this is 1, right? So the radius is 1. And let's see here, let's try to find my trapezoid. They said the trapezoid, one of the bases has to be diameter. So let's put here. So here. So let's do this. This is my trapezoid here. Okay, so this is my trapezoids here, and now I want to find the area of the largest trapezoids here, right? Okay, so now let's try to set. So if this is in touch with this inscribe this circle, so this is x, y, right? Okay, so I know. Okay, so here this is x, this is y here. Okay, so now let's just like we did before. The first things here we want to find is objective. I want to find the area again. So what is the area of the trapezoid? Is you add 2 bases times the height, right? So it's the 1/2. Okay, the height for this trapezoid is what? Is y, right? Is y. So the height, this is the height. Then the one, so this is one side, right? So let's see here, let's use a different color. All right, so this is one side, this is one base of the trapezoid, and this is another base of the trapezoid. So it's the 1/2 the height times the top base plus bottom base. So here the bottom base is 2. And the top base is x plus x is what? Is 2x here, right? Well, we can simplify this one. So this will just be the y plus 1 plus x here. Okay, so this is a pretty, okay, so let's, what do we want to do here? We want to maximize this again, right? Okay, now let's try to find our constraints to see what do we have. Okay, now my job is to try to find the relation between x and y. Okay, because take a look here, right? So for this problems here, for any points on the circle, right? So for example, this is xy is on the circle. Because of the circle, I have one good property. What is that? That means x squared plus y squared is equal to what? Is equal to 1. Correct? All right. So now it's equal to 1. And now if I want to find, now I can find the function of y equal to, so I can say y squared is equal to 1 minus x squared here. Okay, so you can take the square roots and then you plug that in. Well, or I'm going to show you another easy way to do it. So here, we want to maximize these areas, right? So if I let some value t, I would say the t is y squared 1 plus x squared, right? So the reason why, because I have a y squares here, I try to avoid the square roots. So if I can find the maximum value for this one, it's the same. I'm finding the maximum value for the areas, right? So as long as I can find the critical point for this function, because this is the square of this one. So if this is max, this is max, right? But this will definitely simplify a lot of your algebra calculation, because in here, right, I have y squared equal to 1 minus x squared. Okay, so now let's substitute to, the t here instead of, okay, let's get rid of that. Okay, so now let's take a look at the t, right? So t is equal to y squared. Okay, so I can replace it. It's 1 minus x squared. Then this is 1 plus x, the whole thing squared, right? So probably when you take the derivative and then later try to set it equal to 0, this one will be easier, because I know if I maximize the t the same way I maximize the a's here, right? Okay, now let's take a look at the derivative. So the derivative here, so this we're going to use what? We're going to use the product rule, right? So I'm holding the first one is x minus x squared. So move this one down. So it's times 2 is 1 plus x to the first power. All right. Then you're holding the second term, so 1 plus x squared. Then you take into derivative of 1 minus x squared. So it's minus what? Minus 2x here. Now you see how I can do, I have a 2, I have 1 plus x. So let's factor the negative 2. And so here, let me erase it. So this is less, okay, so this is, let's take the negative 2 out, and then I have, this is a common terms, right? So I can factor the 1 plus x out. Okay, so if you factor this out, you factor -2, so this will give you negative. So this is -1 minus x squared. And this -2 out is okay. So you have x1 plus x, right? So it's a very careful algebra skill. So you say -2, 1 plus x. And then here is x squared minus 1 plus x quarter plus x squared, right? Okay, so what do you have here? Then this is -2, 1 plus x. So this is 2x squared plus x minus 1. And then factor, this is 1 plus x. This is the 2x minus 1, x plus 1. That's right. Yeah, okay, so good. So now I will set this equal to 0, like we did for the how to find the critical value. So that's why I get x equal to 1/2 and x equal to -1. And I know x cannot be the -1 because if -1, I don't have any, the area. So x equal to the 1/2 here, right? So now let's check x 1/2 really will give me t is the maxima or not. So 1/2 t prime. So if you choose something smaller than that, so if you choose 0, so this will be positive, negative, positive, but you have a negative in front. So this is t primes, right? So you will get a positive. Then if you get something bigger than 1/2, you say 1, so this is positive, 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 but you have a negative here, so this is negative. So you go to increasing, decreasing. Yes, so this will give you max values here. All right, so now the x equal to 1/2. Now I can substitute to here. So y squared is equal to the 1 minus 1/2 square. So this is 3/4. So y is equal to the square root of the 3 over 2 here. All right, so the x and the y. So after I get the x and the y here, now I want to find the maximum area. I know the x equal to 1/2 will make the t max. So when the t is max, that means my a is max, right? So now my max area will be what? Will just be equal to, you substitute here, right? So it will be the y is the square root of the 3 over 2 times 1 plus 1/2, right? So 1 plus 1/2, that will be square root of the 3 over 2 times the 3/2. So you will get 3 square root of the 3 over 4. That will be the maximum value, the area you can find for this trapezoid. So what did we learn from this problem? What the skill we are using here? So the skill, for this problem, find the constraint is not bad. It's pretty easy. The first problem, find the constraint, is a little bit tough here. So the final constraint is not hard. Then the tricks here, like I'm showing you, is in order to make your derivative and later set equal to 0 easier. So I kind of square the area, I get a t. So I say if I maximize this one, I can maximize the t's here. The reason why I can do that, because if you square it, this is y squared. Now I get to see here, this is y squared equal to 1 minus x squared, right? So it will make the derivatives a lot easier. All right, let's take a look at number 3. Okay, so the number 3 tell you if the two equal sides of an isosceles triangle have length A, find the length of the third side that will maximize the area of the triangle. Okay, so here, this is my isosceles triangles, right? So this side is A, this side is A, right? So now I want to find okay, so this is my what? This is my height, right? All right, just like we did before, I want to find the objective. So what is my objective? I want to find the area. So area is what? So the area is 1/2 the height times what? Times the base, right? So the base, now we can start to mark our value. I say, okay, so if this is x, this is x here. So my base here is what? Is 2x, right? So my areas here, so it's x times what? Times h. Now I want to maximize that. Okay, now my job here is to try to correlate because I have x and h, right? So I need to find the constraints here. Okay, so what is the relation? So the A, this is a constant because this is a fixed. So this is a constant here, all right? So what is the constraint here? Because this one's here, this is the height. So this is the right triangle. So I know what is here, the constraints here is h squared plus x squared equal to what? Equal to a squared here. Then this one, so I can say the h is equal to the a squared minus what? X squared. And then the h will be equal to the square roots of the a squared minus x squared here. All right. And now let's take a look. So when when I substitute there, so my area will just be xh, so it will be x times a squared minus x squared here. If you like, you can try to kind of square this one and to see you will be able to get it easier, you will be able to get the easier derivative. You can do that. In fact, I think it will be. And in here, I want to show you another way and another skill we learned. And we say it's kind of important when we try to find the critical point, right? So in here, I just substitute here. Okay, now I want to find the first derivative. The first derivative is here. Okay, so this one you can say this is a squared minus x squared to the 1/2, right? So you hold the first one, you take the derivative of the first one, so this will be a squared minus x squared 1/2. Then plus x, then you take the derivative of this one, so this is 1/2. This is a squared minus x squared to the negative 1/2. Then chain rule, right? Don't forget the chain rule is negative 2x here. Okay, so now in here, do you remember like when we did, we said if you have like those the negative exponents and here, it's very difficult, right? So the one of the trick we learn is when we factor, we want to factor the smallest or the largest negative exponents here, right? So here, that's why I say, okay, let's factor a squared minus x squared, the negative 1/2 out. Okay, so when you factor the negative one, you want to factor the negative exponents out because these ones here, this is a positive. If you factor the negative, so what is this one going to become to? A squared minus x squared, right? We did this before. And then in here, let's simplify this. This is a 2 and the 2 can cancel. And now you factor that out, you have what? You have what? You will have minus x squared, right? Okay, so now you will have, this is the a squared minus x squared, okay? And x, and now the top is a squared minus 2x squared. Right, then you set it equal to 0. So I know the bottom cannot, x cannot be equal to a because that means you cannot have 2x equal to 2a, right? So x cannot be equal to a. So I know x squared equal to the 2x squared. So what is x squared will be? X squared will be a squared over 2. So what is my x value? X value will be the square root of the 2 here. Okay, so if A is the square root of the 2, then let's see. So my base here, the base will be the 2x, right? So it will be the 2a over square root of the 2, or you can say the square root of 2a. Okay, now let's see my height here. My height is equal to the square root of the a square minus x square. So it's a minus a square to the 2. So the height is the same. So it's a over square root of the 2. All right. So that is a equal to the square root of the 2. So what is my maximum area? My maximum area is x times h. So x is a over square root of the 2 times a over square root of the 2, right? Okay, so what is that? Is a square over 2, right? So that is the that is the maximum triangle area we can get from this isosceles triangle. So what do you learn in the number 3 is here? In the problem number 3 in here, we kind of use this problem to refresh. How do I simplify? If you have negative exponents, right, you can kind of factor that out, and then you set the derivative equal to 0, and it will be easier to solve. Or you can use what we did in the number 2. You can find like the square this one, and then probably the derivative part will be easier. But I just want to show you, kind of refresh the technique you learned. Okay. All right, that's it. That is all the optimization problems we're going to practice. There are some very, very complicated ones, but I think as soon as you can understand these 3 levels of the problems, you will be in a pretty good shape there. All right, that's it. And it's nice to talk to you. And, looking forward to try to work with you for our another set. All right. Okay, bye.